Here's another problem from the U-Substitution handout I gave you, although this problem doesn't require U-Substitution, so they were kind of thrown in as a review, so it's actually an antiderivative worksheet. And this one, as was example 8, we don't really need U-Substitution to do this. So what we can do is we can just break this up into 4 different parts and then use our antiderivative rules to deal with those. So this would be the same thing as the integral of x to the third. I'll just leave it like that. X to the third. And I can write this as x to the 1/3 minus 2x squared all over x to the 1/3 minus 5x all over x to the 1/3 plus 3 all over x to the 1/3, and that would be dx. There we go. And then to simplify each of these, remember when you divide, you subtract the exponents. So this is going to be the integral of x to the, and then this is like 3, which is 9/3, minus 1/3, which would be 8/3. Minus 2 times x to the 6/3 minus 1/3 is 5/3. Minus 5 times x to the 3/3 minus 1/3 is 2/3. Plus 3, and I'll just bring this up as x to the negative 2/3, all dx. Okay, hope that makes sense. And then we'll use our reverse power rule. In other words, we'll add 1 and divide by the new exponent, or multiply by its reciprocal. So that's going to end up equaling x. And if I add 3/3 to 8/3, that's 1. I would get 11/3. And divided by 11/3 or times 3 over 11. Okay, minus 2 times, and then x to the 3/3 plus 5/3 is 8/3. Divided by 8/3 or times 3 over 8. Minus 5 times x to the 5/3. If you add 3/3 to 2/3, you get 5/3. Times 3 over 5, divided by 5/3 or times 3/5. Plus 3 times, and if I add 1 to 2/3, I get 1/3. Oh, I'm sorry, this should have been 1/3. Excuse me, made a mistake here. Bring that up, should be 1/3. Excuse me. And then if I add 1 to negative 1/3, at 3/3, I get 2/3. Sorry about that. You probably were wondering if I would see that. Okay. And plus c. And we can simplify this a little bit. So we'd have 3 over 11 times x to the 11/3. 2 goes into 8 4 times, so minus 3 over 4. X to the 8/3. 5 goes into 5 once, so minus 3, excuse me. X to the 5/3 plus the same old 3, x to the 2/3 plus c. So that's one form of the answer. Now if we notice that if we subtracted 2 from each of these numbers, we would get numbers that are perfectly divisible by 3. So, except for this case, which we would just have 0. So what we're going to do is we're going to factor, and it doesn't matter with the constant because you're just going to get another constant. So we're going to factor out x to the 2/3. And that's going to leave us with 3 over 11. And if I take 2/3, remember when you factor, you subtract. So if I subtract 2/3 from 11/3, I get 9/3, which is 3, so that just becomes x to the 3rd. And if I subtract 2/3 from 8/3, I get 6/3, which is just 2, so I just get x squared. And if I divide 2/3 into x to the 5/3, or subtract 2/3 from 5/3, I get 3/3, which is just x, so minus 3x. And if I factor the x to the 2/3, I just have plus 3. And that's like that, and then plus c out here. So you might see the problem like that. It might have been simplified like that. Then we could always write this as the cube root of x squared times this whole thing plus c. So you could see the problem written like this. I think these are examples of some problems on the 4.5 worksheet, and I think that you see a problem that's in an answer form like this, so this might throw you, so this should help you see what to do there. Okay, so I hope that makes sense.